This is the Alphabet and Grammar of Geometry. Preview video 1.4, Part 2, Brain in Hand, Problem Solving. Take a moment. Sit up tall. Inhale through your nose. Hold your breath. And exhale. Alrighty, taking a look here, we are going to be continuing our process of how to solve more complex problems. The vast majority of your math career is not as something as simplistic as this. 3 root 2 times root 2 is 6. The vast majority of the application of math consists of far more details and complexity. So it's very important you understand this simple concept before we get started. Many of you believe that before you can put forth any effort, you first have to understand. So before you attempt to do a problem or give effort, you feel you must understand it. So the minute, or better, the second you hit the I don't know feeling, many students simply stop giving effort. But in reality, the opposite is true. You first apply effort, and then you get aha, understanding. Effort yields understanding. You don't understand first and then apply effort. So a lot of questions I get here is, well, how do I apply any effort when I don't understand? This is the key to the entire course. 5 things you can do when you don't know what to do. And I'm going to demonstrate this in this lesson. 5 things you can do when you don't know what to do. First, and most important, star that. You always want to read with 3 body parts, 3 times. Finger on paper, lips moving, eyes on text. That's pass number 1. Go back and filter or underline key words. Pay attention to units. Number 2, draw a label list, cross out. Draw a label list, cross out. Physically trace your diagram. This little icon means no naked diagrams. Dress up your diagrams. Something you can always do is ask yourself, what have I learned in my reference booklet? Review your reference booklet. Recite recent revelations. You ask yourself, what can you do instead of should do? Squeeze the sponge is my way of saying squeeze out every drop of information out of the problem. When you work with equations, they have 2 sides with an equal sign in between. And when you do equations, you write a things first, then you do the algebra. And then I'm going to demonstrate a technique called circle, plug, chug. Circling key information, plugging it into the equation. Chug is my way of saying get something done. We're going to do 2 problems together and then 2 problems on your own. Ready? Let me demonstrate what 3 body parts 3 times looks like. I want you to put your finger right at that dot. I have my electronic finger here. I'd like you to read out loud with your finger on the paper as I also read. Read with me out loud. The perimeter of rectangle PQRS is 26 centimeters. The longer side PQ is 3 centimeters longer than QR. Find the area of the rectangle. I'm going to go back and filter. We have perimeter. Is. Watch out for the word is, are, was, were. That's an equal sign. 26 centimeters. We have a longer side is 3 centimeters longer than QR. Our ultimate goal is to find the area. I always like to put a question mark by our ultimate goal. Ready? We're going to draw, label, list, cross out. We're told the longer side is PQ, so I'm going to start my P here. Okay, as you account for items, I have a rectangle, I've labeled it, is 26. Now, length is the longer side, width the shorter. The length is 3 centimeters longer than the width, which would be QR. Longer than, shorter than. Longer than is plus, shorter than is minus. So 3 centimeters longer than the width. Our ultimate goal is to find the area. So we write out the area equation. Okay, now at this point, this is where students tend to get stuck. They're like, I got all this information, I don't know what to do. So you ask yourself, well, what's a really easy thing that you can do? Let me demonstrate what I mean by this. You're given the perimeter. Could you at least write out the perimeter equation? Could you at least write that out? Well, sure, that's easy. There we go. I wrote down the equation. Well, what else can you do? Well, I can circle, plug, chug. Circle and plug it in. I circle the L, I pick up what belongs in the L, and I plug it in. I circle the W. Circling every aspect of the diagram enables to make sure you don't lose a component of your equation. From here, now, it's just basic algebra. Once you find your width, of course you come up here, and that's now 5. So that means our length, 3 plus 5 is 8. Come up here, and now we circle, plug, chug. That's now 8. Width is 5. Therefore, our area is 40. We check for units. Centimeters squared. This page, I'd like you to follow the very same process on your own. So pause the video and restart when you're done. So taking a look at your work, this one we started with area. So we start by writing down the area equation. You should be checking your work in red pen. Therefore, it's 3 times the width, so that's a times concept. So we end up with length times width, 3W times W. W times W is W squared. Divide by 3. W squared is 16. W is 4. Length is 12. Therefore, your perimeter, if you walk it around, is going to be 12 plus 4 plus 12 plus 4. That's 16. 16. Our perimeter is 32. And check units, centimeters. Okay, check your work. If you get it incorrect, I expect a notation to what you're going to do differently next time. Let's go over a more complex problem together, and then you're going to do the last one on your own. Again, reading 3 body parts 3 times. So I'd like you to please put your finger right at that dot, and I want your finger on your paper, reading aloud as I read. Mr. and Mrs. Tumnus wanted to fashion a concrete rectangular patio in their backyard. The width of the patio is 3 feet shorter than the length. The perimeter of the patio is 54 feet. It takes 2, fix that typo, 60-pound concrete bags per square yard of patio. Each bag concrete costs $3.50. Calculate the cost of the concrete for the patio. Alrighty, let's draw, label, list, cross out. So what do we know about the patio? We have length, we have width. It says right here the width is 3 feet shorter than the length. That means, watch carefully, that it's the length minus 3. The length minus 3 is the width. Perimeter, 54 feet. What else do we know? We know for the bags of concrete, we need 2 of them, times 2 for every yard squared of patio, and it costs each bag $3.50 each. Calculate the cost. Okay, notice, very, 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 very important. The units of our patio are in feet. The concrete is talking about square yards. Let's come over here and do a quick study. In your reference booklet, there is this page in the beginning of your reference booklet about converting units. It's super important you understand this. In the first dimension, that's just length, a yard is 3 feet. That's only in the first dimension. Area is in the second dimension. So it's 1 yard by 1 yard, which means it's 3 feet this way, 3 feet this way. Therefore, in a single 1 square yard is 9 square feet. In 1 square yard, there is 9 square feet. So keep that in mind as you're doing this problem. First, we need to get the dimensions because concrete is an area concept. So we need to find the area. Perimeter equals length plus width plus length plus width. Let's circle, plug, chug. That's 54. The length we have just a variable for. Width, we're going to substitute the width with its length minus 3. Length minus 3. Now it's a basic algebra problem. collect like terms. That should be 3. Our length is 15. Our width is 3 feet less, so our width is 12. Okay, so now we have our dimensions. So let's come up here. Now we're going to work on how is this patio. If we're going to go buy cement, how much do we need? So our length is 15 feet and our width is 12 feet. So concrete is a concept of area. So area equals length times width. So we're going to go 12 times 15 in the margin here. So we understand that our area is going to be 180 feet squared. We need 2 bags of cement per a single square yard. And the square yard is 9 square feet. So we're going to divide by 9 feet squared to get the fact that we need, 9 goes 20 yards squared is the patio. And we need 2 bags per square yard. So that's 20 times 2. So we need 40 bags of cement. Our ultimate goal is cost. So we're going to times that by 350. So we have 40 bags at $3.50 each. So the total cost here is going to be $140. Now, these 2 pages you're going to do on your own, and then you're going to restart the video and double check your work. Alrighty, welcome back. Let's see how you did so far. So your area is 108, area's length times width. We were told the length is 3 times the width, so that's 3W. So you end up with 3W times W equals 108. You solve, W times W is W squared. So I have W squared, divide by 3, I get 36. Opposite of squaring is square rooting. I got the width is 6. So far, we know the width is 6 feet. And the length is 3 times, so that's going to be 18 feet. 6 feet, 18 feet. Now we're making a border. A border is perimeter concept. So we're going to find the perimeter. We're going to walk it around. So 6 plus 18, 6 plus 18. That's 24. That's 24. Therefore, my perimeter is going to be 48 feet. We're told in the storyline it takes 3 pots of flowers for each square foot. So for every square foot, we need 3 pots of flowers. That's my attempt at flowers. And the flowers are $2 a pot. So for every square foot, you're going to spend $6 for the flowers. So to figure out the cost, it's going to be 48 feet times 6 per square foot. Students, please avoid using calculators for single-digit multiplication. And your flower pot border is going to cost you $288. Double check your work compared to mine. Now, take yourself just a minute and talk through what are the main concepts you learned in watching this video.